he would now continue with in this class. Okay, so just I think this would be a good time for you to just flip through to see what's happening in chemical bonding. Of course, we have a pending question to ask him about the practical section for the chemistry for the paper three. So yeah, he's going to be with you shortly. Okay, all right.
No problem.
All right, I'm right here with you. All right.
Okay.
Yeah. Saboda, can you hear Mr. Lasisi? I think
Good
she
evening,
just
good evening,
left.
Mr. Ajiro.
Good evening, sir. I think it was
I
maybe a
can't
bit of
hear
a
her
network.
voice again.
Yeah, she just left. I noticed that she just left. Yeah.
Okay, maybe it's the network.
But yeah, definitely. You've started chemical bonding. You've started
Yes,
chemical bonding. She's back on.
I've
She's
done
back on.
electronegativity. I've done the first part. I remember, and I've sent out the note already. That's right. That's right. I remember. Let me bring up the note. Thank you so
Samuda,
much. I appreciate it.
Samuda, can you hear us?
Yes, I can. It
Okay.
disconnected for a while. Yeah.
Okay, that's fine. That's fine.
We have
Yes.
started electronegativity. We've done electronegativity. We said this electronegativity and ionization energy, they follow the same trend. It increases across the period from the first element, the alkali metal, and reaches a maximum at the halogen atom. Therefore, the most electronegative element in the entire periodic table is fluorine. It increases and decreases down the group, right? Have we done chemical bond? Have we done ionic bonding or not?
We only ended at electronegativity.
Okay, so we have to start ionic bonding now, right?
Mm.
I, I don't know if you have gone over the note a little bit. The note I sent. It's okay. So what's ionic bonding? According to your syllabus, can you read it to me? 3.21.
Define ionic bonding as the electrostatic attraction between oppositely charged ions, positively charged cations, and negatively charged anions.
I think that seems straightforward. Am I right?
Yes.
I don't have to explain anything on that. Do you understand that?
Yes, I understand.
Do you understand the statement? Ionic bonding
Yes.
between what? Charges which are oppositely charged. Is that okay? So we are
Yes.
talking about chemical bonding now, right? 1 minute. Chemical bonding. So number one, we are doing that 3.21, 3.21, 3.21. That is definition of ionic bonding. You know, that is short from the syllabus. I don't have to say anything down on that. Ionic bonding, positive and negative ion, they attract themselves. Please don't say that ionic bonding is when a metal loses electron, a non-metal gains electron. Those are
Okay.
the processes that occur prior
Mm.
to ionic bonding.
Okay.
Electron loss, electron gain, becoming positively charged and becoming negatively charged are processes that occur prior to ionic bonding. Ionic bonding is the attraction between ions which are oppositely charged. Do you agree to that?
Yes, I agree.
Example of ionic bonding. So you do example. I have an example in the note. Let me just go over that. I'm going to
Okay.
write it again.
Okay.
Look at it. Dot and cross diagram of ionic bonding. For
Mm-hmm.
MX, where I'm reading from here.
Mm-hmm.
For MX, where M is a what? It's an alkali metal. Alkali metals are group 1 metals. Am I right? Then the
Yeah.
halogens are the group 7 elements. So the alkali metal loses 1 electron. The halogen gains 1 electron. Did you agree? So this
Mm.
electron, this black electron, is from the alkali metal. Do you agree?
Yes.
The halogen initially had 7. So this guy now loses 1 and the guy goes there. So if you are to draw the dot and cross diagram of lithium fluoride, group 1 and group 7 elements of sodium iodide, potassium bromide, sodium fluoride, all of them, this is the answer. Do you agree?
Yes, sir.
You have to show that. Now, what that means is that the alkali metal that initially had 1 electrons in the outer shell has lost that single electron. The outer shell is now empty. That's why I draw it empty. The
Mm-hmm.
outer shell is containing 1 electron. After losing it, the outer shell is now empty. So we have empty shell and 8 electrons. This is for group 1 and group 7 elements. Is that okay? What are group 2 and group 6? Group 2 element will lose 2 electrons, so it's 2 plus. Group 6 you gain 2 is 2 minus. Do you get that?
Mm.
Now, example on that, look at it. Remember dot and cross diagram, dot and cross diagram of ionic compounds. So, for example, magnesium initially was 2H2, oxygen was 2,6, 2 electron comes here. Magnesium now become magnesium 2 plus, now 2,8. Oxygen also become oxygen 2 minus 2,8. Now, magnesium, don't forget this guy now, if you write electron configuration, it is 1s2, 2s2, 2p6 now. This guy, oxygen was initially 1s2, 2s2, 2p4. So initially, pay attention, oxygen was, I'm showing the outer shell alone. This one is the first shell, this is the second shell. Outer shell, look up, pay attention, 1s2. Are you there?
Yes.
Or let me write it out. This guy is 2s2, 2px2, 2py1, 2pz1. So the outer electrons in oxygen atom, let's do it. Look at it. 2s2, are you there? 2px2, 2py1, 2pz1. Do you agree? Therefore, if our oxygen gains 2 electrons, the 2 electrons gained cannot be together. Do you agree? Because the 2 electrons to be gained now, one will come here, one will come here, it now become 2 minus. Do you agree?
Yes.
So yeah, so when a non-metal gains more than 1 electron, and you have to draw that and cross diagram, make sure that 2 electrons gained, they are not together. They can't be together. Look at the way I do it. In IGCSE, we will forgive you if you do something like this. If you do that, go and do this. In IGCSE, we will forgive you. Very level will not forgive you. You want to write O2 minus, you now write it as O, 6 electron in the outer shell, 1, 2, 3, 4, 5, 6. Then the 2 gained by O. You now say it is 1, 2. Okay. In IGCSE, we will forgive you. For IGCSE, we tell you it's correct. But for A level, it's not actually correct. It's
Okay.
not correct. Because the 2 electron gained from the electron configuration of oxygen before gaining the 2 electron, you know that the 2 electron cannot be together. They must be separated. Is that okay? So without
Yes.
understanding, so that's sorted out. What about the third one? What about you are doing something like sodium oxide? When you have 2 sodium and 1 oxygen, look at it. Sodium ion, oxide ion. Do you get it now? Sodium has lost the outermost electron, it's now empty. Second sodium on the left is now empty. Oxygen in the middle has now gained 2. And the 2 it gained, they are separated, they are not together. Do you agree to that?
Yes.
That's sodium oxide. Is that okay? What about aluminum fluoride? Aluminum is 3 plus. Then fluoride. Do you get the point now?
Yes.
Some people do it like this. But this is correct. But some people do it like this. Said, look at it, said, I don't know if the mask scheme allows that. It's correct, but I don't know if mask scheme allows. I'm sure mask scheme allows it. I'm sure this is correct in mask scheme. There's another one of this aluminum fluoride, right like this, aluminum 3 plus, then 3 fluorine. I think it's also correct. 1, 2, 3, 4, 5, 6, 7, 8. You can write this as is correct. Do you get? Can you see now?
Yes,
Meaning
I
that
can.
there is 1 aluminum and 3 fluoride is correct. Is that okay?
Oh, we can
So
draw it like this instead of drawing 3.
Or you can, yes, I'm saying instead of drawing this, and this, you could have just drawn one of these, then put 3 before you draw this one. Is that okay? The way I do it,
Oh, okay.
3 is
Yes.
correct. Is that okay? Same thing goes for
Yes.
sodium oxide. Sodium oxide, that means it should be like 2 of sodium dot, then 1 of oxygen. Or magnesium chloride. 1 of magnesium, then 2 of what? Chloride. 1, 2, 3, 4, 5, 6, 7, 8. Do you get it now? Oh, you should be NGCL, sorry. Something that
Okay.
doesn't make sense to you.
Yes, it does. So
2
that
sodium.
dot is necessary.
Yeah, I'm sure that you can. This is correct. Masking allows it.
Oh, okay.
Is that okay? The dots
Yes.
here represent that the 2 does not transcend to the, you have to put a dot between them. The 2 is only for the sodium, not for oxygen. Do you get the point? This one, second one, the 2 is only for chloride, not for magnesium. Does that make sense? Hello?
Sorry, Mr. Lasisi. I'm yet to get a Wi-Fi router. Right now, I'm hotspotting my laptop with my phone, so it keeps disconnecting.
Okay, it's fine. It's fine.
Yes.
But just make sure that when you are with me, be sure you are responding so that when you leave, I'll know that you're not with me. I'll wait to wait for you. Do you get? Make sure you're
Okay,
always
no,
responding when I say, do you understand? So if I don't hear your voice, I know you are no longer with me. Is that okay? I'll wait to wait for you.
no
Now, we are
problem.
done with that. Let's now do things like, so if you're not going to do things like aluminum oxide, how do you think you're going to do it? Some of the aluminum oxide. That'll be 2 of aluminum, am I right?
Yes.
Then 3 of oxygen. 1, 2, 3, 4, 5, 6, 7, 8. 2 minus. Do you agree? That
We
is
don't
aluminum
indicate,
oxide.
so we
Say
don't
that again.
indicate, we don't indicate which one is aluminium, which one is
Oh,
oxygen. We just,
sometimes you have to put it. Sometimes you put it. That's true. You're right.
okay. All right.
Magnesium chloride. Yeah, it should
Okay.
not be confusing. Sodium oxide. Thank you for calling my attention to that.
Okay.
Aluminium, chlorine. Thank you for that. I'm sure that makes sense. So let's now go and see the next thing here. Look at my notes. Properties of ionic compound. Can you begin to read? Let's explain it. If you understand that, I won't waste time. I'll just skip it. Read fast,
Okay.
please.
Particles, number one, particles present, ions, not molecules.
So ionic
Sodium.
compound don't have molecules. They have ions. What do you know of
Mhm.
particles in chemistry? What are the particles in chemistry? Is it particle? What does it mean? We talked about that one time. Particles in chemistry. What are they? Or particles in science. Number one, could be atoms. Give me an example of something that contain atom. Give me an example. Helium, neon, all those group 8 elements. Argon,
Sodium.
krypton. They are atoms. Give me an
Mhm.
example of molecules.
Sodium chloride.
I mean, the element. Am I right? Hydrogen
Mhm.
is a molecule. Oxygen, nitrogen, ozone, P4, S8, chlorine. They are the same type. Even this guy, C60. Do you know C60?
No.
Do you know the C60? What do you call it? What is C60?
C60.
C60, C60, yes. Have you heard
Uh,
of, fullerene before? Fullerene.
fullerene. No, I haven't.
Okay, okay, hold on. I will divert a little bit. Look at it.
Okay.
Allotropes of carbon. Are you there?
Mm-hmm.
Do you tell me when you know diamond, am I right?
Yes. Graphite.
Graphite.
Mm-hmm.
They are called graphene. You do more later.
Okay.
There's fullerene.
Oh, this one is
Fullerene
fullerene.
example is C60, C120.
Okay.
Yeah, look at this. It's a spherical arrangement of carbon atoms that are pentagonal and hexagonal. This is fullerene, the one in front of you. It's another
All
type of
right.
carbon. And there are 60 atoms. Some of them contain 60 atoms, C60. Some contain 120 atoms, 120. So each
Mm-hmm.
of the carbon atom in fullerene, how many bonds do they have? Yeah, look at me. Tell me the answer. Each of the carbon atom in fullerene, how many atoms do each of them have? How many bonds do each of them have? Hello?
Mm.
It's in front of you. Don't think. The answer is right in front of you. Tell me the answer.
60.
Each of the corner. What do you say?
60
Each of the
bonds.
corner is a carbon atom. How many bonds do each of the carbon atom have in fullerene? What's the answer?
You're saying each of the what?
Each of the carbon atom in fullerene. How many bonds do they have? Copy
1, 2, 3, 4, 5.
Three. No. Look at the carbon. Look at the dots. The junction. Look at that junction now.
I'm looking
Look
at
at
it,
it.
but I'm seeing.
Yeah, look at
Okay.
this. When you just focus on this.
Okay.
Focus on this. How many bond? Three. Look at the junction. Three bond. Is that okay? To another one. Three bond. Am I right?
Oh, okay.
Do you
Yes.
get now? Three bond.
Mm.
Three bond. Three bond. Do you get? It's
Oh,
almost like graphite. Remember that
okay.
carbon atom is graphite. We'll do that on that state of matter later. Don't worry. We'll talk about it. But just know that fullerene is also a molecule. I'm saying that atoms of carbon are diamond, graphite, graphene, fullerene, etc. These are the four common ones. Is that okay? They
Yes.
are allotropes of carbon. All of them contain carbon. When you
Okay.
eat graphite in air, in oxygen, diamond in oxygen, graphene in oxygen, fullerene, all of them form CO2. Then they all contain carbon atom. Do you agree to that?
Yes.
Now let's go back. We'll address later. Now come back here. Molecule can be elements or compound. Give me an example of compound and molecule. CO2 is a molecule. Water is a molecule. Ammonia is a molecule. Methane is a molecule. Ethanol is a molecule. Hydrogen peroxide is a molecule, etc., etc. Is that okay? So particles in chemistry could be number one, atoms. Could be what? Molecule. What's a
Okay.
molecule? How do you define a molecule? A what? A
So,
group of covalently bonded atoms.
mm,
Do you agree? The
yes.
atoms may be the same type or different type. It does not make any difference to us. If what connect the atoms together is a what? Is a covalent bond, then you have formed a molecule. In
Mhm.
S8, which kind of bond connect the sulfur atoms together in S8?
In S8, which what?
S8 here, the
Mm-hmm.
sulfur atoms, which kind of bond connects them together? Covalent bond.
Covalent bond.
Because
Yes.
sulfur is a non-metal. In chlorine, the atoms are connected by covalent bond. Why? Chlorine is a non-metal. Bromine, the atoms are connected by what? Covalent bond. It's a non-metal. Do you get the point now? When we have two or more atoms connected by covalent bond, then we have what we call a molecule. Do you get the point now? A molecule
Mm-hmm.
is a group of atoms which are bonded by covalent bonds. Is that okay?
Mm-hmm.
If the
Yes.
atoms are the same type, then it is an element. If the atoms are different, then it's a compound. So a molecule can be an element, a molecule can be a compound. Do you understand that?
Mm-hmm.
So which other particle do we have? Four particles in chemistry. Number one, atoms. Number two, molecules. Number three, ions. Where
Mm-hmm.
do we have ions? In ionic compound,
Mm-hmm. So,
NaCl, the ions are what? Na plus and Cl minus. Does it make sense?
yes.
In calcium fluoride, what are the ions in calcium fluoride? Ca2 plus and 2F minus.
Mm-hmm.
So number one, particles can be atoms, particles can be molecules, particles can be
Ions.
ions, then particles can be electrons. Where do we have electrons as particles? In metals. Let me show you.
A lot, and you're like, okay, do you have a private tuition? Don't you have? Do you have? And yes, Ajiro Tech do have a private tuition. So by my right, you can see that we have for the EdExcel and Cambridge IGCSE. And yes, we do have for all subjects. Okay, all subjects. Okay, the popular ones that's always been in demand is mathematics, English language as a second language. Okay, we have physics, we have biology, we have chemistry, and we have um, you know the flagship, which is ICT, just here and there. We also have business studies. So if you're interested for a private tuition, um, I think all you have to do is send an email to the sales team at ajirotech@gmail.com, and they would reply to you, talk about your time zone, talk about, and the fees really quite affordable. Really, it's really quite affordable. It's when you look at it across other tutoring service, I think this is the one that's quite affordable, and you get the very best of service. We also have for the E levels as well, um, and also for the EdExcel. So we have for the Cambridge E levels and EdExcel E levels. Okay, and we have also across the subject mathematics, which is usually the hot cake when it comes to E level, mathematics and chemistry, and then biology. These are usually one of the ones we have in demand always, all the time. Even physics, for E level. So all you have to do, if you're watching this right now and you are interested for a private tuition, then you can do yourself a solid, okay, and send an email to the sales team at ajiro@gmail.com, and they'll reply to you. And the good news about this is what I've discussed with the sales team is we've tried as much as possible to see how we can subsidize the amount according to countries, so it doesn't really look very, very heavy. Okay, so this is really important. Yes, we do charge in pounds, but again, we try to be as much as possible considerate to your countries, and we don't just skyrocket the price. No, because at the end of the day, we know how it feels, and we really want you to actually get the best of service, and again, be able to afford it from the comfort of your home. So again, Agile Tech private tuition is currently ongoing. You can enroll yourself for the IGCSE, and then for the E levels. Again, for the IGCSEs, these are the subjects, and for the E levels, these are also the subjects. So again, what are you waiting for? Just send an email to the system. If you're an IGCSE student preparing for IGCSE, if you're watching this in 2024, 5, watching this in 2026, watching this in 2027, we're currently ongoing, and this is actually a good time for you to actually explore, and then get it tailored to your own needs. So trust me, you don't want to miss out.
Then electrons are there.
Mm-hmm.
What do you call those electrons?
The lattice.
The whole thing is lattice. The positive guys
See,
are
of
called cations.
delocalized.
I
Sorry.
like that. The localized electron. I like that. The localized electron. So,
Yes.
what are the particles present in the metal?
The
Ions and electrons.
mhm.
Do you get the concept now?
Yes.
Particles present in the metal, ions and electrons. Particles
Mhm.
present in ionic compound, ions only. Particles present in covalent substances, molecules. Then particles present in noble gases, atoms.
Okay.
Repeat that. Particles in noble gases, atoms. Particles in noble gases are what?
Atoms.
Atoms. Is that okay?
Yes.
Particles in noble gases are what? Are atoms. What are the particles in covalent substances?
In covalent
Particles present in
ionic.
covalent substances, what are they? Particles present in covalent substances. What are they? Are what?
Molecules.
Thank you, molecules. Thank you, molecules.
Mm-hmm.
What are the particles present in the metal lattice?
Metal, it's atoms and ions
No.
and electrons.
Thank you, ions and electrons. That's good. What are the particles present in an ionic compound?
Ions.
Ions, thank you. So do you get the concept now? You know what particles mean in chemistry now? I'm going
Yes,
back
I
now.
guess.
So I'll now come back again and I'll say, so particles present in an ionic compound are ions, not molecules.
Mm-hmm. Okay.
Number two, ionic compound in their solid state, they are poor electrical conductor. Why? Tell me. It's in the notes.
Because ions are not mobile. They
They are
don't
not
move.
mobile. They are strongly bonded together. They can't move.
They can't
So they
move.
can't carry
Yes.
electric charges. But what about this guy and this guy? The ions, are they mobile or not?
They are mobile. The
So they will be
acquiescent.
a good conductor.
Yeah.
So they conduct electricity. What do we call a substance that conducts electricity because it has mobile ion? What do you call such substances? In electrolysis, what do you call it? A substance that conducts electricity because it has mobile ions. What do you call such substance? All of them are conductor, but if you want to be more specific, a substance that conducts electricity because of mobile ions are called electrolytes. Have you heard of that before?
Electrolyte. Yes, I have.
Electrolytes.
Okay.
Look at this again. I have to divert. All this thing I'm saying, they are useful for you. Please, I beg you.
Mm-hmm.
Electrical conductors. We have electrolytes and what? And electrodes. Electrodes have mobile what? Mobile electrons. They have what? Mobile ions. Do you understand it now?
Yes.
A electrode, all metals are electrode, all metals. Mobile electron means the localized electron. Do you get the point now?
Mm-hmm.
Good. All metals, and there's one non-metal that's an electrode, that's graphite. Am I right?
Yes.
What about mobile ions? Ionic compound studies in aqueous state,
Mm-hmm.
ionic compound in what? In molten state. In molten state,
Liquid.
liquid. Thank you for the correction. Do you get now? So there are two
Mm.
particles that make a substance to conduct electricity. Pay attention. If a solid substance conducts electricity, it is because of mobile electrons. If a solid substance conducts electricity because of what? Mobile electron. If a liquid or a solution conducts electricity, it is because of mobile ions.
Okay.
Do you get that now? Moving or mobile ions.
Okay.
This guy electrolyte is either what? Aqueous
Or
or
liquid.
what? Or liquid.
Mm-hmm.
Electrodes are always solid. What is the exception to that? All electrodes are solid except one. Which one is that?
Graphite.
Graphite is a solid now. Mercury is a
Or
liquid
mercury.
metal. Mercury is a what? A liquid what? Metal. Is that an electrode or an electrolyte? It's an electrode. Why? It has mobile electrons. It has
Mobile.
delocalized or mobile electrons. Is that okay? It's a metal. Electrolyte is either a solution or a molten compound. Is that okay? Electrolytes. They are either solution. This guy, they are either what? Solution of ionic compound or what? Molten ionic compound. Molten ionic what? In that
Compound.
case, a compound. But electrons are mostly elements. They are elements. They are either metals or graphite. Am I communicating, class?
No, I
Let's come back
understand.
here. So ionic compound in their now number 2 is telling you that ionic compound in their solid state do not conduct electricity. But in their aqueous state or in their molten state, they are good electrical conductors because they have mobile ions or moving ions or mobile ions. Is that okay?
Yes.
Number 3, ionic compound. Why are they always solid? Number 3, can you read it for? Tell me the answer.
They usually
Why are they
exist as solids because strong ionic bonds between their charged ions.
They are what? They are oppositely charged ions.
Oh,
There's a
that's why.
strong force between the two ions. So it takes a lot of the energy is so strong that
Mm.
you pack them together and make them a solid. Do you get the point now? Ionic compound are never liquid. Let me get understand. Look at this. Ionic compound are solid. Ionic compounds are usually what? So now look at this. Mercury is a liquid. Bromine is a liquid. Now mercury bromide is a solid. Can you imagine? Because it's ionic.
Mm-hmm.
Mercury is a liquid. Chlorine is a gas. Mercury chloride is a solid. Can you see now? Because the
Yes.
bond between them is so strong that they can't be liquid, it can't be gas. The bond is so strong that we'll pack them together. The stronger the bond between the particles, the more likelihood that they will exist as a solid. Do you agree to that?
Yes, I agree.
So that's it. Ionic compound usually solid. Why? Because of strong electrostatic attraction. Electrostatic attraction between the what? They're
The
going the
opposite.
oppositely charged ions.
Okay.
The forces are so strong that they will
Mm-hmm.
not likely be liquid or gas. They will likely be solid. Is that okay? Next one, number
Yeah.
4. Why do you have high melting points and boiling point? Yeah,
I should read.
they have giant ionic structure, strong ionic bonds. Therefore, large amount of heat is required to break the bonds apart.
Mm-hmm.
Their structure is giant.
Giant.
Now, giant, I'll teach them more of that in chapter 4. They have giant
Okay.
structure. Let me give you an example. The bone of a rat is a simple bone. I can break with my hand. Am I right?
Mm-hmm.
The bone of a mouse or a rat. But the bone of an elephant is a giant bone. I can't break it with my hand. Do you understand the concept now? Giant
Yes.
and simple. One is giant and big. The other is simple and tiny. Do you get the point now? So they
Yeah.
are always giant structures. Is that okay? So they have high
Mm.
melting and boiling point because of giant structure, strong bonds, and therefore large amount of energy required. Is that okay?
Yes.
Number 4. Number 5, can you read it for me?
Most ionic compounds dissolve in polar solvents. Polar solvent,
Like
what?
water. Like water, like.
Like water, because the
Uh-huh.
latter can hydrate the ions. Sodium chloride solid
Everybody, pay
plus.
attention now. Let me explain to you. Solubility of ionic compound in water. Solubility of ionic compounds in what? In water. Pay attention, please. Water is covalent. I'll teach you later. Don't ask me now. I'm going to teach you later. Water is covalent, but it's also polar. Water is like this. It has a partial positive, partial negative, partial positive. Ionic compound also contain Na plus and Cl minus. So if I draw underwater here, water has partial charges. I'll explain to you later why it is so. Now look at this NaCl. If Na should go to the right, Cl minus go to the left. Which of the atoms in water will attract Cl minus? Is it O or H?
Which of
Cl
the
minus
atoms?
go to the left.
Mm-hmm.
Cl minus this guy goes to the right. This one goes to the left. Which of the atoms in water, H or O, which of them will attract Cl minus?
H.
Look at the charges. Unlike charge, thank you, H. Unlike charges attract. So this guy will likely go toward this guy. Do you agree?
Yes.
This one will most likely go to this guy. Do you agree?
Mm-hmm.
What it means? When you write NaCl aqueous, it actually means Na plus aqueous and Cl minus aqueous. Na plus aqueous actually means this. It means this. It means Na plus surrounded by water molecules. That's what Na plus aqueous. In recent, Na plus surrounded by what? By water molecule. Is that okay? Can you see where
Mm-hmm.
they are? Because Na
Yes.
is plus, O is minus.
So it attracts.
Minus,
Yeah.
minus.
Minus.
Now, what does Cl minus aqueous means? Means Cl minus surrounded by water molecule. Can you see where they are? Can you see where they arrange themselves?
Mm-hmm.
Why Cl minus is minus and H is plus. So H point towards Cl, O point outside because unlike charges attract, like charges repel. So when you say Cl minus, so pay attention. So Na plus aqueous is called hydrated sodium ion. Hydrated what? Sodium ion. What about Cl minus aqueous? Hydrated chloride ion. Why is this reaction possible? Because NaCl has both positive and negative. Negative Na plus can attract negative part of water, which is oxygen. I mean, sorry,
Positive.
positive Na plus can attract negative part of water, which is oxygen.
Yes.
Then negative Cl minus can attract positive side of water, which is H plus. So this
Mm-hmm.
is possible because so ionic compound can dissolve in water because now read it now. Which understand now, read it now. What can you read it now?
Most ionic compounds dissolve in polar solvent like water because the latter can hydrate the ions. So
Is that okay?
sodium
Can
chloride
so this thing is called like this is called hydration. This is called what do you call this?
hydration.
What hydration when you
Mm-hmm.
hydration.
Okay.
Hydration is possible because there is Na plus that can attract O minus, and there
Mm-hmm.
is Cl minus that can attract H plus. The covalent compound don't have Na plus or Cl minus. So most covalent compound they don't dissolve in water. Is that okay? They don't have plus and minus. Is that okay? Ionic
Yes.
compound has plus and minus, which can attract water molecule. Water will now attract to them. Now, that process of being attracted to water molecule, you call hydration. Is that okay? So simple, just
Yes.
say ionic compound are solid water because water can hydrate their ions. Because
Mm-hmm.
the latter mean water. That means the latter. Water can hydrate their ions. That's just why they are soluble in water. And I've told you what hydrate means. Is that okay? Hydrate
Yes.
means each ion being surrounded by water molecule. O will point to Na, H will point to Cl minus. Does that make any sense? You are done with that.
Mm-hmm.
So let's go back to our syllabus and see then we are done with this ionic compound. That's it. Next one, metallic bonding. Can you read?
Define metallic bonding as the electrostatic attraction between positive metal ions and delocalized electrons.
Do you get it? You know, we have said that before, but today, am I right? So
Mm-hmm.
it's,
Yeah.
it's somewhere they rearrange the syllabus. Let me locate it for you.
Oh, okay.
Metallic bonding.
Metallic bonding involves the strong electrostatic attraction between lattice of positive ions and C of delocalized, moving or mobile electrons.
a lot, and you're like, okay, do you have a private tuition? Don't you have? Do you have? And yes, Ajiro Tech do have a private tuition. So by my right, you can see that we have for the EdExcel and Cambridge IGCSE, and yes, we do have for all subjects. Okay, all subjects. Okay, the popular ones that's always been in demand is mathematics, English language as a second language. Okay, we have physics, we have biology, we have chemistry, and we have um, you know the flagship, which is ICT, just here and there. We also have business studies. So if you're interested for a private tuition, um, I think all you have to do is send an email to the sales team at ajirotech@gmail.com, and they would reply to you, talk about your time zone, talk about, and the fee is really quite affordable. Really, it's really quite affordable. It's when you look at it across other tutoring service, I think this is the one that's quite affordable, and you get the very best of service. We also have for the E levels as well, um, and also for the EdExcel. So we have for the Cambridge E levels and EdExcel E levels. Okay, and we have also across the subject mathematics, which is usually the hot cake when it comes to E level, mathematics and chemistry, and then biology. These are usually one of the ones we have in demand always, all the time. Even physics, for E level. So all you have to do, if you're watching this right now and you are interested for a private tuition, then you can do yourself a solid, okay, and send an email to the sales team at ajiro@gmail.com, and they'll reply to you. And the good news about this is what I've discussed with the sales team is we've tried as much as possible to see how we can subsidize the amount according to countries, so it doesn't really look very, very heavy. Okay, so this is really important. Yes, we do charge in pounds, but again, we try to be as much as possible considerate to your countries, and we don't just skyrocket the price. No, because at the end of the day, we know how it feels, and we really want you to actually get the best of service, and again, be able to afford it from the comfort of your home. So again, Agile Tech private tuition is currently ongoing. You can enroll yourself for the IGCSE, and then for the E levels. Again, for the IGCSEs, these are the subjects, and for the E levels, these are also the subjects. So, again, what are you waiting for? Just send an email to the system. If you're an IGCSE student preparing for IGCSE, if you're watching this in 2025, watching this in 2026, watching this in 2027, we're currently ongoing, and this is actually a good time for you to actually explore, and then get it tailored to your own needs. So trust me, you don't want to miss out.
Do you understand what
Metals,
that means?
yes, I
Yeah,
understand.
go on. Go on, please.
Metals are good electrical and thermal conductors because of the presence of mobile electrons.
You can say mobile or delocalized, they mean the same thing. Go on.
Okay. Metals are malleable and ductile because bonds between cations and electron, C, or cloud readily break and reform when worked upon. Metallic bonding is non-directional. Single ions or sheets of ions can slide past each other. Electrons in a crystal may be replaced by others since they are
Let me
mobile
explain to
lattice.
you. Thank you. Now, what that means is this. Why are metals malleable? This is metal. So let me write again. Metals are what? Malleable and what? And ductile. What does malleable means?
We can bend it into shapes, no?
Can be bent or beaten into sheets. What about ductile?
Tactile. I'm
Can be drawn
forgetting.
into wires.
Why is
Can
okay.
be drawn. into wires can be fitting into different shapes. Look at this, a metal. These are the delocalized electron. Is that okay? When you apply a pressure on them, apply a pressure or stress up or force, if you apply a force on them, force applied on them, what happens is this: the ions will slide over each other and maintain a different position. Can you see what happened? They will slide over each other, they won't break away. They are being glued together by the delocalized electron. Let me give an instance. You and your friend, 5 of you, you go to the swimming pool. When you jump into the swimming pool, each of you and your friend, all of you, you are the cations. The water in the swimming pool are the delocalized electrons. So the water glue all of you together. Is that you cannot break away from each other. Do you get the point now? The water,
Yes.
so it's like, or another way, 20 of you are in a room. Each of you are cation in the metallic lattice. The air around you, the air around you, the air around you is the localized electron. Do you get the point now? So the air is going to glue all of you together. You cannot break away from each other. Do you get the point now? That's what happened here.
Yes.
So so these are the cations. So they don't break away because they are being glued or held together by what? By the delocalized electron. Now look at the electrons now. Is that okay? Can you see now? They can also differentiate, they don't break away. So metals are malleable and ductile because, number one, because the bonds, the C of the readily breaks and reform again. Number one, the C of electron, because C of electron C, readily break and reform. That's number one, when worked upon. Then again, heat of cation can what? Can
Can
slide
slide.
past each other. Two reasons. The bond can easily break and form. Let it break, it form immediately. Don't let them go. Then again, the slits can slide over each other. Is that okay? That's why
Yeah.
metals are malleable and ductile. So what do you mean by non-directional? Let me explain that to you. I said something that I said, they are non-directional because if you have a metal ion like this, if a metal ion is here, the delocalized electron can either come from anywhere. Can come from either if like from the top, from the side, from anywhere they will attract themselves. But it's not so in covalent bonding, it's not so. So just know that I will explain to you later. When you just know that metallic bonding, ionic bonding are non-directional. In covalent bonding, hydrogen must come from a particular direction to react with chlorine. It can't just come from any direction. When you must
Okay.
come from a particular direction to react, that is directional. But when you come from anywhere, you can react anyhow. That's non-directional. Is that okay? In covalent bonding and hydrogen bonding is directional. Covalent bonding, when I enter covalent, I will explain to you hydrogen bonding. These two guys, they are directional. They are what? They are directional. You must come from a particular angle to form covalent bond. If not, it will not agree with you. Let me give you an example. Look at it. Look at this. Look at this. Look at it. I want to form ammonia. Nitrogen is number 2,5. Hydrogen is number 1. Hydrogen number 1. Hydrogen number 1. Are you there? Now they want to form with nitrogen. Nitrogen now say my outermost electron. I have 2s2, 2px1, 2py1, 2pz1. If hydrogen is to come and form covalent bond with nitrogen, this is nitrogen, right? Hydrogen is to come. Will it come from this direction? No. It must come from here. Say hydrogen, come here. You are bringing your own electron.
Yes.
That's correct. It must not come from here. That's correct. Then from here. That's correct. It can't come from here. It won't work. The guy say, hydrogen, what are you doing? That's where I have one electron. Go there, go and join in. Don't come here. So covalent bond is directional. To form a covalent bond, you must bring one electron. I also bring one electron, right? And that's only work if you come to the side where I have one electron. You don't go anywhere to form bond with me. You must say, guy, go to my leg. My leg has one electron. Go there, go and form bond with my leg. Don't come to my head. My head don't have one electron. Don't come there. Do you get the point now? So we must come from a particular direction. Therefore, covalent bonds are directional. That is why in biology, all those biomolecules you study, they have definite shape. Enzymes have definite shape. And it has an active site in which only some molecules can fit in. So covalent bonds are directional. Molecules of life, they are covalent bond compounds. Protein, DNA, all of them, they are covalent compounds. Now, covalent hydrogen bond are also directional. Is that okay? We'll do more on that later. Is that okay? That's all about ionic. That's all about metallic bonding. Is that okay?
Yes.
We are done with metallic bond. Next one. Number 3.4. Yeah, read now.
Covalent bonding and coordinate bonding. Define covalent bonding as electrostatic attraction between the nuclei of two atoms and a shared pair of electrons.
Yeah. So let me draw a diagram for you. I have to draw something for you. Comparative bonding. I'll call it comparative bonding. Comparative bonding. Ionic, nature, particles involved. I'll do all the 4 of them for number 1. Ionic bonding. It is electrostatic in nature. That doesn't mean between opposite charges. Which particles are involved? Cation and what? And anion. Do you agree?
Yes.
Number 2, bonding. Number 2, covalent bonding. No, metallic bonding. Metallic bonding, is it also electrostatic or not?
Electrostatic.
Electrostatic means between charges that are opposite. Is metallic bonding electrostatic or not? It is.
Yes.
Why? Positive cations and negative electrons. Do you agree?
Yes.
So we have cations here, particles involved, and what? The localized electron.
Electrons as well.
So it is also electrostatic. Covalent bonding, you just read that now. Covalent bonding. Go back, you read it again. Read it again. It is what?
Bonding, covalent bonding as electrostatic attraction between.
So actually, every bond is electrostatic.
Electrostatic.
It's
Okay.
also electrostatic means between opposite charges. Who are those involved? What's involved? The nucleus, the nuclei, and the shared electron pair. I will explain that to you now.
Okay.
Number 4, which I'll teach you later, hydrogen bonding. is also electrostatic. Who are those involved? This guy and this, I'll teach you later, or this, or this. Partial positive of hydrogen and partial negative of oxygen, fluorine, or nitrogen. Is that okay? So all types of bond, let's just say all bonds are electrostatic in nature. Let's go and start covalent bond now. Why? So let me open covalent bonding. So now covalent bonding. Come and see this covalent bonding. Covalent. It's like this. Look up. Nucleus contain protons, so nucleus is positive. The second nucleus also contain nucleus, contain proton, which is positive. The electron from the first guy, electron from the second guy. Who is attracting the electron? The nucleus on the right attracting the two electrons. Who is attracting the electron? The nucleus on the left attracting the two electrons. So how do we define covalent bonding? The electrostatic attraction between two nuclei, am I right? And a shared pair of electrons. That's covalent bonding. The two nuclei, they are pulling the two electrons to themselves, right? The red nucleus is pulling it. The black nucleus is also pulling it. So the pull of the two nuclei on the two electrons, what we call covalent bonding. Is that okay?
Yes.
Do you get it? It's not just electron sharing. It's more than electron sharing are the processes that occur before the bonding really occur. The actual bonding is the electrostatic attraction between two positive nuclei. Let me put that with two words. Positive nuclei and a shared pair of electrons. Of course, electrons are negative. Two positive nuclei and a shared pair of electrons. Is that okay? Does that make any sense?
Yes.
Thank you so much. Now, bonding in the following. Let's go. So that one is in my notes. Yeah, look at my. Can you read my note, please?
I should read. Involves overlap
Yes.
of It involves overlap of atomic orbitals as a result of sharing of electron pairs contributed equally by the two atoms, usually nonmetals involved. An
Go
unpaired
on.
electron an unpaired electron is required from each of the atoms involved to form a covalent bond.
Can you stop there?
Mhm.
Covalent requirement for covalent bonding. Requirements for what? Covalent bonding. Pay attention, please. Pay attention. Carbon
Yes.
says I'm number 6. I'm 1s2, 2s2, 2p2. That means 1s2, 2s2, 2px1, 2py1, 2pz0. Look at carbon. How many unpaired electrons do carbon has?
How many what?
How many unpaired electron? Unpaired electron. Electron are not paired. How many unpaired electron do carbon has?
2.
Thank you so much. Based on this, Tamuda, carbon can only form two covalent bond. Because I said it in my note that and I said an unpaired electron is required to form each of the atom involved to form a covalent bond.
Okay.
Mr. Carbon, your outermost shell contains two electrons only. So, Mr. Carbon, I'm sorry, you can only form two covalent bond. He said, no, but I want to, if I form two, come and see carbon. Come and see carbon. Carbon says, carbon, 2s2, then maybe, hold on, maybe hydrogen. Hydrogen, pay attention, oh, hydrogen, hydrogen. Then carbon say 2s2, 2px1, 2py1. Is that carbon? Do you agree to that?
Mm-hmm.
But hydrogen now say, me, I'm 1s1. Hydrogen say I'm 1s1. It's okay, no wala.
Okay.
Hydrogen 1s1, 1s1. Now look at carbon. Is it complete 8?
No.
It's having 6. No, it's not balanced. Carbon now
Yes.
say, I can't do that. But they say, Mr. Carbon, the requirement is that to form a covalent bond, you need an unpaired electron. Mr. Carbon, I'm sorry, you cannot form covalent bond. It's not possible. You can only form 2. You know, what do I do? Carbon now, so I'm going to do something here now. Carbon here. In this one I've shown now. Carbon has incomplete octet. Carbon has incomplete octet is a state when you have 8 electrons in your outer shell and then you are stable. Mr. Carbon, in this state you don't have complete 8 electrons in your outer shell. Therefore, I'm sorry, Mr. Carbon, you are still unstable. You know, say, what can I do? So with this thing, we call this one, we call it ground state electron configuration. Ground what? State electron configuration. In its normal state. Carbon now say, can I rearrange my electron? He said, how? He said, come and see what I'll do. Come and see what carbon did. Well, carbon on its own is 1s2, 2s2, 2px1, 2py1, 2pz0. In its ground state, do carbon has an empty orbital or not?
You're saying does carbon
Carbon,
have an empty?
does it have an empty orbital or not? Yes, this is an empty orbital. Empty
Oh, the
orbital.
PNP.
Do you agree? There is no electron there now. It's empty.
Mm-hmm.
Do you agree? Carbon now
Yes.
say, can I push electron from here and take one here? I will now become this. I'll become 1s2, 2s1, 2px1, 2py1, 2pz1. Carbon say, can I do that? We now say a carbon in this state is called excited state.
Okay.
The carbon that we know normally is called ground state. Because carbon says for me to form 8 electrons in my outermost shell, to have 8, I must have 4 unpaired electrons. So I can share all the 4. 1, 1, 1. I will now have 1 to myself. So I will now have 8. So in this state, now carbon now say, okay, let me now form now. Come and see carbon now. Carbon says 2s1, 2px1, 2py1, 2pz1. Can you now say now? How do you now say, let me come? How do you now say, I'm coming? Hydrogen. 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 And you now see now. So in this state now, carbon say, I now have 8. That is for carbon to react. It must undergo excitation. This process is all called what? Excitation.
Excitation.
When you promote electron between subshell within the same shell, you cannot bring from 1s to 2p. It's not allowed. But we need the same shell. Shell number 2, shell number 2, shell number 2. Do you get the point now? You can only
Yes, I do.
promote electron within subshell of the same shell. You cannot bring from 2s to 3p. It's not allowed. The energy requirement will be too much. You cannot do that. But going from 2s to 2p is allowed. 3s to 3p is allowed. 3p to 3d is allowed. Do you get the point now? So the concept is this. To form a covalent bond, you need an unpaired electron. Go back to my notes. Now look at it. Hydrogen normally form one covalent bond. Do not have any electron left behind again. Halogens normally form one covalent bond. They will now have 3 electrons left behind. 3 lone pairs left behind. I will show you now. Nitrogen 2, oxygen 2, 2, nitrogen 3, 1, carbon 4, what? 4, none. Let me give you a compound now. Look at this compound. The compound may not exist. Don't worry yourself. Hydrogen, 1 covalent bond, carbon, oxygen. Whether the compound exists or not, that's not the issue. I'm just seeing the principle of forming this. Carbon, hydrogen, chlorine, carbon, nitrogen. Let me draw now. Let me draw as much as I can. Carbon single, carbon 2 bond, yeah. Carbon, carbon, oxygen. You get the concept. Just relax. Hydrogen 3, 1, 1, 1. Carbon 1, 1, 1, 1, 2, 2, 3, 1, 2, 1, 1. Yeah, that's correct. Nitrogen is complete. No, 2, 1. Where about oxygen? I need oxygen single bond oxygen. Oxygen single, oxygen, nitrogen, nitrogen. Just hold on. I'm teaching the concept of chemistry. Now you get this. This is the basis of organic chemistry. No, let me use nitrogen here. That's correct. Let me use nitrogen. Nitrogen, oxygen. Okay, let me change this to oxygen then. Oxygen, it's touching the top. Let me bend it. Let me just bend it so that I can get it. Oxygen, hydrogen. Now look at this. Look at all the carbon atoms. How many bonds they form? Also, look at all. Yeah, I'm taking them one by one. No, maybe carbon 1, carbon 2, carbon 3, carbon 4, carbon 5. Carbon 1, how many bonds does it form? How many covalent? Each of the line means one covalent bond, and it means 2 electrons, one from the first atom, one from the second atom. So each line you see here is a covalent bond, one and containing 2 electrons, one from the first atom, the other from the second atom. Do you get the point now? So let's go. Carbon number 1, how many bonds does it form?
1, 2, 3, 4.
Thank you. In what way? 2, 1, 1. That means 2, 1, 1. 2
Yes.
down, 1 there, 1 there. Thank you. Where about carbon number 2? How many bonds does it form?
So 1, 2, 3, 4.
4.
That
Is that correct? In what ratio? 1, 1, 1, 1. Do you agree? Are you getting that?
Yes, I do.
Carbon number 2, it forms 4 bonds in the ratio of 1, 1, 1, 1.
Yeah.
4 single bonds. What about carbon number 3? How many bonds does it form?
4.
So in what ratio? 3, 1. Do you agree? 3 to the
Yes.
right, 1 to the left. I like that. What about carbon number 4? How many bonds does it form?
It forms 4. 1, 1, 2.
Thank you. I like that. Smart girl. Number 5.
4, 2, 2.
Thank you. I like. So carbon can. So this meaning carbon do this. This is carbon. Carbon do this. Can either form 1, 2, 3, 4. Or carbon can form 2, 1, 1. Carbon can form 3, 1. Carbon can form 2, 2. But after forming those bonds, there will not be any electron left for him again. So we say carbon has no lone pairs. So 4 bond pairs, no lone pairs. Is that okay? No electron left on him that is on his own. You understand lone pair later? Let me teach you. Yeah. Now I'm talking carbon. Let's go for nitrogen. Yeah. Let me use a blue bond to get that. This is the basis of organic chemistry, and you must get it right. Covalent bonding is more important than ionic bonding. Molecules of life are covalent. DNA, protein, amino acid, enzymes, all of them, they are all covalent substances. keratin in your hair, in your nail, all of them are covalent substances. So we need to understand covalent bond because it's the basis of life. Is that okay? Now carbon one, nitrogen one, nitrogen two, nitrogen one. How many bonds does it form?
3.
Covalent bond. How many electrons does it have in the outer shell? Why nitrogen? Why will it form 3 covalent bonds? Yeah, let's go. Nitrogen. Look at it. It is 1s2, 2s2, 2p3. What does that mean? 1s2, 2s2, 2px1, 2py1, 2pz1. Mr. Nitrogen has 3 unpaired electrons. It can form 3 covalent bonds. This guy
Yes.
will now be electrons that are in the outer shell, not involved in bonding. We call it lone pair. This will not be the lone pair. So nitrogen, after forming 3 covalent bonds, will have 2 electrons left. Look at it. Can you see the 2 electrons I put there? That's how nitrogen is. Always. After forming 3 covalent bonds, now have 2 electrons left to himself. Do you agree? Same thing with this nitrogen. 2 electrons left to himself after forming covalent bond. This one also. Then the covalent bond nitrogen is can either be 1-1-1 or 2-1 or 3. In fact, it must have 3 covalent bonds. Do you get the concept?
Yes.
Let's go for hydrogen. Hydrogen number hydrogen 1, hydrogen 2, hydrogen 1 and 2. Look at them. How many bonds they form? 1 bond. Hydrogen has only 1 left and use to form bond. Doesn't have anything left. So 1 bond pair hydrogen. What about oxygen now? Mr. Oxygen, let's go and see oxygen. Who is? Oxygen is number 8. 1s2, 2s2, 2p4. Meaning 1s2, 2s2, 2px2, 2py1, 2pz1. Mr. Oxygen has 2 unpaired electrons. After using those 2 electrons, we use this to form what? To form covalent bond. To what? To form what? Covalent what? Bonds. These 2 will now remain as what? Lone pairs. Remain as what? As lone what? Lone pairs. So oxygen will form 2 covalent bonds. There are 2 pairs of electrons left unreacted, right? Let's go. So oxygen 2 covalent bond, then 2 lone pair. That's always how it is, always, all the time. Oxygen against 2 covalent bond, 2 lone pairs. 2 covalent bond, 2 lone pairs. 2 covalent bond, 2 lone pairs. That's oxygen for you. It's always, that's how it is, always, all the time.
Okay.
Then now, halogens, all halogens. Halogens, how many unpaired electrons they have? They only have 1. Look at halogen. Fluorine, number 9, is 1s2, 2s2, 2p5, which means 2s2, 2px2, 2py2, 2pz1. That's only 1 unpaired electron. So can you form 1 covalent bond? You do not have 3 lone pairs. You have 3 lone pairs. After forming covalent bond, you are come and see fluorine. So after using 1, you have 6 electrons left. 1, 2, 3. Where is chlorine? Oh, there's no chlorine there. It's okay. That's fine. Now, how do we prove that this thing is correct? Pay attention. Each atom at the end of the day we have 8 electrons. Look up. Pay attention. 2 electrons for fluorine, then 6 around fluorine, making 8. Do you agree? Nitrogen, 2, 2, 2, 6. Then 2 around nitrogen is making 8. Each line means 1 covalent bond. Each line means 2 electrons. Each line means 1 bonding pair. Each line means 1 bonding pair or 2 bonding electron. Each line means 1 bonding pair, means 1 covalent bond. Each line means 2 bonding electron in it, 2 bonding electrons. Each one from each of the atoms involved, right? 1 electron from each of the atoms involved. Do you get the point now?
Yes.
One line means one covalent bond. One line means one bonding pair. One line means two bonding electrons, each one from the atoms involved. Do you get the point now? Now let's go to
Yes.
covalent bond now. You get the concept now. Now we are done with this. So look at it now. Example, look at water molecule. Do you agree that's water?
Mm-hmm.
Oxygen, two bonding pair, two lone pairs. Look at hydrogen peroxide. Each of the oxygen has two bonding pairs, two lone pairs. Do you agree?
Which one are we looking at?
Hydrogen peroxide, the one next to water,
Okay.
to the right.
Yes.
Hydrogen peroxide. Each
Mm.
O has two bonding pairs, two lone pairs. Is that okay?
Mm.
Let me draw that and cross for you. Let me draw that and cross for you so that I can understand. Look at it. Hydrogen peroxide. Hydrogen, oxygen, oxygen, oxygen. 1, 2, 3, 4. 1, 2, 3, 4. Then, of course, then hydrogen. That's hydrogen peroxide. Do you understand it? So how do I
Yes.
draw it? I can draw like this. H. Oh, I didn't complete this. Cross dots. So I'm drawing hydrogen peroxide and let's go. I'm drawing it. Let me draw it in the way you understand it very well. I want to
Okay.
really get this thing very, very well. Okay, it doesn't really matter. Yeah, H join to O, to O, join to H. Two lone pairs on each oxygen.
Mm-hmm.
That's hydrogen peroxide. Do you understand it now?
Yes, I
So
do.
Tamuda, how many bonding electrons are in hydrogen peroxide?
Bond
How many
electron
bonding electrons are in hydrogen peroxide?
3.
What do you say the answer is?
Bonding electrons.
Bonding
I'm counting
pairs.
the number of electrons, not the pairs.
Bonding,
3.
bonding pairs, 3. Bonding
Mm-hmm.
electrons, 6. Because each pair means 2 electrons. Bonding electrons, 6. Do you agree? No story now. Do you agree?
Yes.
Bonding pair. This is a bonding pair, 1. Bonding pair, 2. Bonding pair, 3. 3 bonding pairs. Now, bonding electrons inside the pair. Each of the pair means 2 electrons, right? So bonding electrons, 6. Do you agree?
Mm.
Are you sure you understand that?
Yes, I'm very sure I understand.
Thank you. And let's go back to our work. So water, I've done water. Oh, what's going on? So look at it. Water is correct. Hydrogen peroxide is correct. Look at ammonia. Nitrogen must have 3 covalent bonds. It should not have 1 lone pair. The
Mm-hmm.
first compound here is the third compound after hydrogen peroxide. This one is ammonia. What's happening again? I think the pen was working now. It's okay, I'll use my hand. I beg you, not waste my time. Now, this is ammonia. Ah, hey, hey.
It's
Okay,
working.
it's working with my hand. This is what? This is ammonia. This is
Mm.
hydrazine. You understand the hydrazine now? Each of the, look at the hydrazine. Nitrogen is still having how many bonds? How many bonds is
3.
hydrogen having? 3. What about each of the hydrogen?
How
One, one,
about that?
one, right?
Mm.
What about each of the hydrogen? One, one, one. Look at the next
Mm.
compound. It's called the one below water is called hydroxylamine. Do I
Okay.
obey the rule? Look at the rule. Do I obey it? Nitrogen 3 bond with
Mm.
1 lone pair.
Mm.
Oxygen 2 bond with 2 lone pair. Do I obey the rule?
Yes.
Thank you. What's happening now? Oh, this pen. Oh my God. Hold on, please. Oh my God. The battery. Hold on. Oh, I didn't know.
Mm.
It's working. Yeah, let's go. Look at this guy. Hydroxylamine. Nitrogen must have. So how if I'm to draw it? N H
Mm.
H O H. Two lone pairs on oxygen, one lone pair. They agree. That's it. They
Mm.
made the rules. And then like hydrogen, nitrogen, hydrogen, hydrogen, oxygen, hydrogen, nitrogen, hydrogen, hydrogen, nitrogen, nitrogen, hydrogen, nitrogen, 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 oxygen, oxygen, hydrogen. Then oxygen has four left for himself. All of them have 888 except hydrogen, which has two like helium and it's stable. Do you agree? That's compound.
Mm.
If they give you 1,000 of this kind of drugs, you can get all of them without missing one. Just understand the concept, you will find understand that carbon, nitrogen, all of them, the way they are. Yeah, okay, you can find your way around them. So let's go. Now look at this. How do you draw this? Look at it, pay attention. C2H6. How do I draw it? Look at it. H C C H H H H H. Do you agree? So if I
Yeah.
make it, do you understand that diagram?
Okay. Yes.
What about C2H4? Look at it now. CC H H H H. The carbon is not complete. What do I do?
Lone pairs.
Carbon don't have lone pairs.
Mm.
Make it double here.
Or double bond pair.
Do you agree it works?
Yes.
What about C2H2? HCCH. Carbon is only having two bonds. You know, it's not. What do I do? Make it one, make it under one again.
Mm-hmm.
Carbon must have four bonds. That's the truth. And it does not have lone pairs again. So you must, if you need to put up bond, put double bond to complete it. If there are no hydrogen again to complete it, is that okay?
Yes. So I need to master that table that says they have this amount of lone pairs and bonds.
This table, I think so.
Okay.
And I do it, I think I do it there. We owe it there also. No. You have to understand the table, yes.
Okay.
Now, yeah, you have to understand the table and then look at this structure that contains almost all of them. Do you get? Carbon must
Yeah.
have four bond and no lone pairs. To master this table, you have to master
Okay.
it. Is that okay? Good.
Yes.
Phosphorus. This is a mistake. Oh my God, how did I make this mistake? Oh, phosphorus in the same group with nitrogen. So lone pair should be one, not two. Do you agree?
Okay.
Phosphorus and nitrogen, so it should be lone pair one, like nitrogen. Do you get?
Mm-hmm.
And I've sent to you already. Am I right?
Yes.
So please note that area. I may have to
Agree.
send it. If I need to send, I will send it.
Okay.
Phosphorus and nitrogen are in the same group. Both of them we have three bond pairs and one lone pair.
Okay. Okay.
Sometimes also can now have five if you have any lone pair again. I'll show you those examples. Don't worry, because it's the expansion of octets. I need to do this one for now. So let's go back here. Yeah. So look at carbon dioxide. Do you understand it?
Mm-hmm.
Carbon is having four bonds. Each of the O is having two bonds. Look at the next guy. 18 C2H4. 18 C2H4. Carbon is having how many bonds? 18. Carbon is having how many bonds? 4 bonds.
Mm-hmm.
Each of the O is having what? So each of the O is, each of the carbon hydrogen is having 2 bonds. Is that okay?
Yes.
Do you get it now? Now let's go. What next again? The next one, look at the compound that is followed. COCl2. Do you understand that one? This guy, do you understand it?
Yes, I see.
This guy.
Mm-hmm.
You
Carbon
understand
is
it? Thank
4.
you.
Mm-hmm.
Each of the chlorine is having 2 and 1 bond, and everything has 2 bonds. Is that okay?
Yes.
So do you understand this one also? Hydrogen cyanide.
Nitrogen 3. Yes, I do. Carbon 4.
What about this guy?
4. Yes, I understand it.
Thank you. Thank you so much. These are the guys that we are to know. Now, let me now go back to syllabus. You have to do some. I don't know if I do all of them. Go back to syllabus. Now, look at the guys you do. Yeah,
Mm-hmm.
hydrogen. You know hydrogen. Hydrogen is what? So you have done this
1.
hydrogen, oxygen, nitrogen. Yeah, hydrogen, oxygen, nitrogen. Let's go. You want that according to your syllabus. There you do. So I'm mistakenly skip anyone.
Okay.
Says you know the hydrogen is this. Oxygen is this. 2 bonds, 2 lone pairs. That's O2.
Yeah.
Nitrogen is this 3 bonds with 1 lone pair. Each of them is that okay?
Mm-hmm.
After that, we've done this. Then chlorine,
Chlorine.
hydrogen chloride. Chlorine is this lone pair, lone pair. Am I right?
Mm-hmm.
Hydrogen chloride is this 3 lone pairs. Am I right?
Mm-hmm.
You don't have to tell me so I can explain to you.
Okay.
The next one, carbon dioxide ammonia. We've done this already. We've done
Mm-hmm.
this CH4. I've done this,
Mm-hmm.
I've done this, I've done that. I've done that. Is that okay?
Yes.
Do you agree? So I've done the waste
I,
time on it. Are you getting me?
yes.
We have understood that covalent bonding under the shell electron. Now say there's now called exceptions to octet rule. Octet rule says that you must have 8 electrons in your outer shell to be stable. But there are some molecules that don't have up to 8. And there are those that have more than 8. How do we sort them out? Some don't have up to 8, others have more than 8. Is that okay? So we call
Mm-hmm.
it exceptions to octet rule.
Okay.
Exceptions to octet rule. So it's in the notes. I don't have to write it. Can you look at it? You look at it. Can you read? Exceptions to what?
To
Octet rule. There are some molecules they don't have up to 8 electrons in their outer shell in a compound, and yet such molecule exists. We call them, what do you call them? Electron deficient molecule. Can you see there?
Yes, I can.
So example of that, aluminum chloride, boron hydride, beryllium chloride. I need to draw that for you to prove a point to you. Exceptions to octet rule. It's not taken off. This covalent bond is the most important topic you ever learn in chemistry. Is for A level, as far as A level is concerned, I'll say to what? To octet rule. As far as A level is concerned. Because it's the foundation for your organic chemistry. And organic chemistry carry too many marks in A level. You know, you understand covalent bonding, organic chemistry is a work over, you understand it perfectly well. Now let's go. Number 1. Electron deficient molecule. What does that mean? Molecule that don't have up to 8 electrons in the outer shell. What group is beryllium? Group 2. It shares one with chlorine, one with chlorine. How many electrons is beryllium now having in the outer shell now? Look at beryllium now. How many electrons does it have in the outer shell now? Outer shell electron. 4. I like that.
Mm.
Ah,
A lot, and you're like, okay, do you have a private tuition? Don't you have? Do you have? And yes, Ajiro Tech do have a private tuition. So by my right, you can see that we have for the EdXL and Cambridge IGCSE, and yes, we do have for all subjects. Okay, all subjects. Okay, the popular ones that's always been in demand is mathematics, English language as a second language. Okay, we have physics, we have biology, we have chemistry, and we have um, you know the flagship, which is ICT, just here and there. We also have business studies. So if you're interested for a private tuition, I think all you have to do is send an email to the sales team at agiotech@gmail.com, and they would reply to you, talk about your time zone, talk about, and the fee is really quite affordable. Really, it's really quite affordable. It's when you look at it across other tutoring service, I think this is the one that's quite affordable, and you get the very best of service. We also have for the E levels as well, um, and also for the EdXL. So we have for the Cambridge E levels and EdXL E levels. Okay, and we have also across the subject mathematics, which is usually the hot cake when it comes to E level, mathematics and chemistry, and then biology. These are usually one of the ones we have in demand always, all the time, even physics, for E level. So all you have to do, if you're watching this right now and you are interested for a private tuition, then you can do yourself a solid, okay, and send an email to the sales team at ajiro@gmail.com, and they'll reply to you. And the good news about this is, what I've discussed with the sales team is, we've tried as much as possible to see how we can subsidize the amount according to countries, so it doesn't really look very, very heavy. Okay, so this is really important. Yes, we do charge in pounds, but again, we try to be as much as possible considerate to your countries, and we don't just skyrocket the price. No, because at the end of the day, we know how it feels, and we really want you to actually get the best of service, and again, be able to afford it from the comfort of your home. So again, Agile Tech private tuition is currently ongoing. You can enroll yourself for the IGCSE, and then for the E levels. Again, for the IGCSEs, these are the subjects, and for the E levels, these are also the subjects. So again, what are you waiting for? Just send an email to the sales team. If you're an IGCSE student preparing for IGCSE, if you're watching this in 2025, watching this in 2026, watching this in 2027, we're currently ongoing, and this is actually a good time for you to actually explore, and then get it tailored to your own needs. So trust me, you don't want to miss out.
So it's having four. Thank you. It's not complete. It's having four. What about this
Yes.
guy? Boron is group three element. He shares one with fluorine, one with fluorine. How many is boron having now? Six. 4
6 years.
electrons for beryllium. For boron, 6 electrons. It's not complete. Is that okay?
Yes.
Aluminum is also three element. He shares one with chlorine, one with chlorine. It's also having 6 electrons. So there are some molecules that don't have up to 8 electrons in their outer shell. So they still, you call them, what do you call them? Electron deficient molecule. They are exceptions to octet rule. Do you understand that?
Yes, I understand.
There's such molecule, they can now form what we call dative bonding. Let me give you an example of that. Look at it. Pay attention. Boron is number 5, 1s2, 2s2, 2p1. You can now say I'm actually 2s2, 2px1, 2py naught, 2pz naught. In its ground state, how many empty orbitals do boron have?
Two.
2.
Two.
Do you say 2?
Yes.
You are correct. That's me. Boron now say I want to form 3 covalent bonds. I will have to
Mm.
undergo what's called excitation. Remember I said it before.
Yes.
We will now bring one electron, bring it and bring it here, right? You now
Mm.
become what? 2s1, 2px1,
Two P Y.
2py1,
Mm.
2pz0. Here can only form one covalent bond. Am I right? Because one unpaired. But here, how many can they form? can now form 3 covalent bonds. Am I right?
Mm-hmm.
3 covalent bonds. But it now has an empty orbital. Do you agree?
Yes.
Do you agree? So look at it. So this is BF, ZBF3. We are talking about BF3. So look at BF3. Hold on. 1, 2, 3. Fluorine now say, okay, let me form bond with you, or let me use hydrogen. BH3, hydrogen, hydrogen, hydrogen. Can you see? It's not complete. It's having 6, it's not complete.
Yes.
Now, ammonia will now say, let me help you now. Come on, ammonia, look at ammonia. Ammonia says, have a group 5 element, nitrogen. I mean, pay attention though. That is a group 5 element. Say nitrogen is says 2s2, 2px1, 2py1, 2pz1. That's nitrogen. Is that okay? Hydrogen now join it. Hydrogen now say, okay, let me join you. Hydrogen now says, let me use under hydrogen comes with 1 electron, hydrogen, covalent bond with hydrogen, covalent bond with hydrogen. You now say, nitrogen now say, I have 2 extra. Mr. Bono, don't kill yourself. Let me help you. I'll bring my 2 to you. We share it together. You will not bring anyone. So this guy will now react. This guy will react. The product is this. Boron. Then nitrogen. And I bring the 2 electron here. Look at the 2 here. He brought them here. Don't not bring anything. 1, 2, 3. Then the green bar. 1, 2, 3. Hydrogen, hydrogen, hydrogen. Then Bono says, I'm also here. 1, no, I didn't shade it. It just 1, 2, 3. Hydrogen now comes again and join hydrogen, hydrogen, hydrogen. Now look at the compound form. Now look at Boron. Does it have 8 or not?
It now has 8.
Boron, does it have 8 now or not? In the final compound, does it have 8 or not?
It has 8 now.
You. So the bond formed between boron and hydrogen, what kind of bond is that?
Between covalent.
Boron and hydrogen.
Covalent.
Call it this.
Oh, coordinate bonding.
We share 2 electrons. You are the one that brought the 2. I didn't bring any. We still
Okay.
share 2. Do you get? But somebody brought the
Yes.
2. The other person did not bring anyone at all. If you brought 1 and I also brought 1, that's covalent. But if you brought 2, I brought nothing. That's covalent,
Oh,
coordinate covalent, which is dative bonding.
oh,
Do you
okay.
understand that?
Yes.
Good. So now, what is the condition for you to form dative covalent bonding? Pay attention, pay attention. There are 2 atoms involved here. We say nitrogen is the donor atom. Boron is what? Acceptor atom. Do you agree?
Yes.
Do you get the concept?
Mm.
What is the condition for nitrogen to be donor atom? Has a lone pair to donate. Am I right?
Yes.
Do you get it? Do you get the English?
Mm.
Has a lone pair to donate. Look at ammonia. In ammonia, nitrogen has a lone pair can donate. What about boron? What will make this guy qualify? Has an empty orbital to accept. Has an empty orbital to accept the lone pair. Do you get the concept? So 2
Mm-hmm.
atoms are involved. The donor atom has a lone pair. The acceptor atom has an empty orbital into which electron can be accepted. So my point is that all those electron deficient molecules, they can accept lone pairs and become stable. Do you get the point now? All
Yes.
those electron deficient molecules, they can accept lone pair and become normal now. Do you get the point? Bear in mind.
Yes,
How do we draw this guy? How do we draw this guy? Let me draw this guy for you. How do we draw it naturally? You need to get that. Look at it. BH3. You need to know how we draw it in diagrams. Plus N with a lone pair. H, H, H. Two of them, they have to combine to give boron H, 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 then black, nitrogen H, H, H. Do you understand this?
Mm-hmm.
Showing that the lone pair is coming from nitrogen to who? To boron. So
Boron.
this addition, we call it addition compound. How many bonding pairs are there? In this guy, how many bonding pairs?
7.
What? 7. Do you know
7.
7? That's correct. Thank
Mm-hmm.
you. How many covalent bonds?
1, 2, 3, 4, 5, 6.
6. How many dative covalent bonds? 1.
1. Mm-hmm.
Dative covalent bond is 1. Do you get the point now? Now, how many bonding electrons? 14. But there are 7 bonding pairs. Do you get the point now?
Mm-hmm.
Do you understand that? Good.
Yes, I do.
Good. That aluminum also, the guy is aluminum. Look how much aluminum. This is aluminum. Chlorine, chlorine, that's best aluminum. Each of the chlorine now has 3 lone pairs. Do you agree?
Mm-hmm.
Aluminum is not having complete octet. It's having 6 electrons in the outer shell. The second
Yes.
aluminum, okay, look at the second guy. Chlorine, chlorine, chlorine. Can you see? They want to combine it. How? Say yes, you can help each other. Come and see what they will do. These guys are so funny. I think they talk to each other and they help each other. Come and see what they do. Yeah. The guys say Al, chlorine, chlorine, chlorine. Second guy, Al, chlorine, chlorine, chlorine. Are you there?
Mm-hmm.
The chlorine in the middle now say, guy, use one of your lone pair to form a dative bond with me.
Okay.
Let my own chlorine also dative bond with you. Can you see what they form?
Mm-hmm.
Do you get the concept?
Yes, I do.
Such that the chlorine in the middle now has only 2 lone pairs left, whereas others have 3 lone pairs. Others have 3 lone pairs. The chlorine in the middle also here has only 2 lone pairs, has formed dative bond with 1, whereas others have 3 lone pairs. Cambridge said in Al2Cl6, how many lone pairs are present? Cambridge question. Now tell me, in Al2Cl6, how many lone pairs are present? Go ahead, I'm waiting. Let me write it very well so that I can look at this. In Al2Cl6,
How many
how
lone
many
pairs?
lone pairs are present? What? In Al2Cl6, how many lone pairs are present? Lone pairs, 3, 3, 2, 2, 3, 3. Simple, all right?
Yes.
That's 16, 16, simple. Do you agree?
Mm-hmm.
How many bonding pairs are present?
1, 2,
1, 2, 3, 4, 5, 6, 7, 8. 8 bonding pairs. Don't forget that the dative bond is coming from chlorine to aluminum and not the other way around. It's coming from where? Chlorine to aluminum, not the other way around. The
Oh,
chlorine
okay.
atom is the donor atom. Aluminum is the acceptor atom. Is that okay? So no mistakes of drawing it the other way. You'll be wrong. It's coming from chlorine to aluminum. Please bear that in mind. I'm not to get dot and cross of this. Let me do dot and cross for you. I hope you understand it, and I will solve the class. Let's go. Aluminum, chlorine, chlorine, chlorine. Then now, aluminum, chlorine, chlorine, and the third chlorine. No, it's not fine. Let me make the guy big enough. So the other no, you get it now. Don't worry. Chlorine, 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 then chlorine. Do you understand it? Let's go. Look at it, compare the diagram. They are the same. Chlorine, 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 aluminum. Then now, chlorine, chlorine, aluminum, chlorine. So this guy, this is a dative bond, dots, dots. There are only two dots left. Then dots, cross, dot, cross, dot, cross. So three dots on each of the chlorine. Then three dots on chlorine. Then let me do the red guy now. Then this is also dots, dots. It's covalent dative bond. Then dot cross, dot cross, dot cross. Then three dots on each of the chlorine. Three lone pairs on each of the chlorine. Then two lone pairs on this central chlorine. Look at it, does it make sense to you? Compare them. Compare them. It makes sense, right?
Yes, it does.
Good. So that is the question on this IALCL3. I've seen up to 20 questions on it. There's many questions on the mental. It's not like you draw the structure. Ask about lone pair there, how many density bond is there, what's the bond angle, or what is the shape. There was many things on it. Is that okay? That's this guy. He's a special guy. I'm sure that makes sense. So
Yeah.
let me be sure let me start with this particular place. So number one is electron molecule. Am I right? Number two is now molecules that contain more than 8 electrons in their outer shell. We call it expansion of octets. The first three I show you, they don't have up to 8 electrons. Therefore, they can accept lone pair through dative covalent bonding. Is that okay? But this one, they have more than 8 electrons in their outer shell. How is that possible? Of course, very possible. How do we know that? Let me prove it to you from the fundamentals. So we're talking about expansion of octets. Expansion of octets. If you remember period 1s, 2 electrons only, period 1. Period 2, call 2s2, 2p6. Am I right? What about period 3? 3s2, 3p6, 3d10. So period 3 element can contain up to 18 electrons in the outer shell. Do you understand that?
Yes.
And period 4 also can contain more than also contain 18 or more. Do you agree to that? So for you to have expanded octet, expansion of octet that is more than 8 electrons in the outer world shell. For you to have this, you must be a period 3 element minimum. Period 2 cannot do it. Period 1 cannot do it. Only period 3, period 4, period 5, period 6 can do it. Do you get the point? They are the one that can contain more than 8 electrons in their outer shell. Does it make any sense? Good. Now look at it. I think I have the example in your notes. Look at the notes. I didn't explain it. What group is sulfur? What group is sulfur? Look at this. Let me quickly write it and round up. Now, please let me give an example of sulfur. Sulfur is number 16. It is 1s2, 2s2, 2p6, 3s2, 3p4. I'm after this. Am I right?
Mm-hmm.
So that means it's what? 3s2, 3px2, 3py1, 3pz1. How many covalent bonds can sulfur have in this case?
This can have 2.
Thank you. Example, hydrogen sulfide, SHH. With two lone pairs. What are the lone pairs now? The lone pairs are what? 3s2, 3px2. Do you agree?
Yes.
Thank you. But someone say, I can do something. Someone say, don't forget I have 3D. You said that's true. Look at someone, it has 3D. Say my 3D is just empty. I can promote electron and become like this. 3s1, 3px1, 3py1, 3pz1, then 3d1. There are 5 orbitals in 3D, 3d1. In this state now, how many? Oh, 3s2, this should be 2, sorry. If we move from this guy to 3D, we have 3D not, right? It's away from here to what? To 3D. Now became this. You get? In this state now, how many unpaired electrons do sulfur have?
4. 1, 2, 3, 4.
Thank you. Someone say, I cannot form SO2. Sulfur can form 4 bond 1, 2, 3, 4. Will you have a lone pair?
Yes, it has
How many lone pair will you have now?
1.
Thank you so much. 1, 3s2, that's 3s2.
Mm.
Let me see if I can understand it. Let me write it in black. When we are reading it, you get it.
Okay.
3s2. This guy is the one that is the lone pair now. 3s2. Now, this other one, let me write them in black. Let me write them in blue. That you can, when you are reading it, it will make sense to you so much. Lone pair, lone pair. That's 3s2, 3px2. That lone pair. You can use that 2 lone pairs. This is the first exact test. The guy say, can I go further again? Say yes. I don't say, let me go further. Let me go further. Say I can become this again. I can become 3s1, 3px1, 3py1, 3pz1, 3d2. Do you agree? That's 3d2. 1, 1. Now, in this state, how many unpaired electrons do sulfur has?
1, 2, 3, 4, 5, 6.
6.
Yes.
How many covalent bonds can I form? 6. So this guy say I can form it. Look at it. In SO3, sulfur forms 6 covalent bonds. In SF6, sulfur forms 6 covalent bonds.
Okay.
In H2SO4, sulfur forms 6 covalent bonds. Can you see what sulfur is doing? So you call expansion of octet. Now, in SO3, how many electrons in the outer shell of sulfur now?
In SO3.
Yeah, how many electrons in the outer shell of sulfur now in SO3? Yes. How many covalent bonds does he have? Tamunda. SO3, how many covalent bonds does sulfur has?
6.
12 electrons, simple. Each covalent bond means 2 electrons. Am I right? So sulfur has 12 electrons in the outer shell now. Do you agree?
Yes.
What about in SO2? In SO2, how many electrons do sulfur has in the outer shell now? In SO2.
That's
What do you say?
4.
In SO2, how many electrons do sulfur has in its outer shell
8.
after forming SO2? How many covalent bonds does it have?
It has 4.
So that's 8 electrons. Then what about the
Yes.
lone pair?
The lone pair is 1. Oh.
So that's 10 electrons. Do you agree? 10 electrons now. Yeah,
Mm-hmm.
12 electrons. Right now, see now. We are saying
Yes.
that some atom can expand and accommodate more than 8 electrons in their outer shell. Is that okay?
Yes.
Only period 3 element downward, period 3, period 4, period 5, period 6 can do that. Period 1 and 2 cannot do that. Is that okay?
Yes.
Oxygen and sulfur belong to the same group. Though sulfur can expand its octet and contain more than 8 electrons in the outer shell, oxygen cannot try that. They can't try it. Do you agree to that? Because
Yes.
Mr. Oxygen is this. That's why. So NCl, look at this compound. I'll stop here. NCl3 exists. PCl3 also exists. They both have one lone pair length. Phosphorus and chlorine, they're in the same, I mean, nitrogen and what? And phosphorus are in the same group. Is that okay?
Mm-hmm.
Chlorine, 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 chlorine. But again, nitrogen cannot form NCl5. It does not exist. You know why? Nitrogen is number 7. It is 1s2, 2s2, 2px1, 2py1. You cannot promote electron form. There's nobody here. It is empty. You
Yes.
can't promote electron. So by can have is 3. The phosphorus can promote. Phosphorus is number 15. It is 1s. It is that's the last number I'll give you. It is phosphorus number 15. It is 1s2, 2s2, 2p6, 3s2, 3px1, 3py1, 3pz1, then 3d naught. Am I right? Can promote from
Mm-hmm.
and bring. Am I right?
Yes.
And now become what? 3s1, 3px1, 3py1, 3pz1, 3d1. Can I have electron? 5
Okay.
compared electron. Therefore, can form 5 covalent bonds. But can nitrogen do that? No. Nitrogen cannot do that.
Mm-hmm.
Nitrogen cannot expand its octet, but phosphorus can expand its octet. Is that okay? Why?
Yes.
Phosphorus has a 3d orbital into which electron can be excited. Is that okay?
Mm-hmm.
Nitrogen does not have 2d. Is that okay?
Yes.
I think that makes sense. Okay. So
Yes.
we will stop here. So we stop here now. So this is the last I just talked to. I just talked to this now.
All right.
No. Let me see. I've talked to this.
Okay.
I just talked to this. You guys stopped.
Okay.
Is that okay?
Yes,
That's
sir.
where I stopped.
Mr. Ajiro.
Hello, Tamida, can you hear me?
Yes, I can hear you.
Okay, good. So, I hope you enjoyed the class today.
Yes, I did.